Hello, all. Welcome back to the new session on internals of Hudi table types. In this video, we will recap Hudi table structures, and then we'll go over the different table types supported by the Hudi, and then we understand the difference between both of those table types. So before we started, we let's understand the data files you use as part of the Hudi. So Hudi tables have the two kinds of files, data files. So one is called the data files or the base files, and the other is called the log files. So the data files is of the Parquet files that contain the actual data of the table, and the log files are the files where you have updates applied or the deletes applied on your original data, so on which original data sets. So the log files is like an updates happens or deletes happen to the original data of your table. So we'll see the both of them in action in the next slide. So that is about very high level. There are two kinds of data files for the Hudi tables. One is the data files and other is the log files. And along with the data files, we have seen the meta files. Hudi also maintains some meta files. This is like the brain of the Hudi, like where it will maintain all the related uh, details of the table. So the one most important property file is the Hudi.property file. This Hudi.properties file will contain the like the table name, table type, what is the table type, and partition columns used for it, and the key generator class. So here let's see the key generator class. What is the key generator class? Key generator class is like in the Hudi, each record that you inserted into the table will need to have a unique id that uniquely identifies that record. So that unique identifier either you can configure from your data that you are receiving, or else you can ask Hudi to generate that unique identifier for your records. That's about the key generator class. And the remaining are like you're familiar, like the partition columns. Like if you wanted to partition the table data, that partition column information, all this information will be stored here. So let's take a look at one quickly Hudi property file. Yeah, if you see here, Hudi.properties file, I have the key generator class that I mentioned, and time zone, and the one property we are interested is like the table types. What is the table type? Whether it's a copy and read or merge and write table. We will go over the in soon. And there is one more thing like the table mm, partition columns, like what are the partitions used for loading this data, and the base file format like the Parquet. So base files is always base or data files is always going to be um, same Parquet files only. Okay, and the table name. So these are some of the very important parameters that will stored in this Hudi.properties file, and this Hudi.properties file used by the both the readers and writers. They both adhere to this property file while interacting with the Hudi tables. Okay, and so if you see, that is about the Hudi.properties file, and along with this Hudi.properties file, there are some transaction meta files. These files contains the actions happening on the Hudi tables, and these files are of either Avro or JSON files. So, and whenever these files are generated, whenever the read write happen to that, there are a different there is a certain format for these files. Like it will have the timestamps when that action happened, and what is the action type, and what is the action state, whether it's completed, failed, or in progress or completed or something like that. So action type is like a timestamp value. This is like this value keep on increases. You do the actions on the tables, like the insert, updates or deletes on the table. And the action type is like the what kind of action happened as part of this transaction, whether the it's a commit or it's a delta commit or compaction or clean the happen. So it's like what kind of actions, whether the records are committed or log file are generated, all of those things. And then the action state is like whether it's in a requested, in flight or completed. Requested means the action is requested for it. In flight means action is in progress, and completed is like the action is completed. So if you can see in this screenshot, you can see the different action types. Let me open one of the table I have. So yeah, if you see here, this is the table. Under this table I have the sorry, this is the table I have under this Hudi. Under this Hudi we have the Hudi.properties file, and all these actions, the transaction actions happening on that table. That is what we mentioned it here, transactional meta files. So these meta files are used for recreating the table state. You can time travel back. You can find the what is the status of my table a few hours back or few days back, and also you can use this transactional meta to generate the CDC on the table, change data capture. Okay. That is about the Hudi meta files. So just to recap, the Hudi tables have the two kinds of files. One is the data files. The data files of the two types, either data or base files. They and the log files. And there is the meta files. The meta files will contain the actions happening on the Hudi tables, along with the Hudi.properties files, where both the readers and writers will add it to this Hudi.properties file. So having said that, let's understand now. Now we have some basic idea about the different files generated by these Hudi tables. So then it's a good time to jump onto the different table types on the Hudi. Hudi has the two types of table types. One is the copy and write tables and merge and read tables. So let's understand what is the copy and write tables. So the copy and write table is these are the tables where whenever you do an update or whenever you add a new records to the tables, it's always generate a new Parquet file. To give an example, assume that I have a table which having the data files 1, data file 2, and data file 3. And assume that I am updating the data available in these two records available in these two file data file 1 and file 2, and I am adding a new data that is not available in any of those data files. Then when the write happens, it's basically rewrite the data file 1 to the here. If you see the data file version 1, it was returned to the data file version 2, and the same way that data file 2 also returned as a new file. And along with the new updates are happening, right? So assume that that is going to be as part of the data file 4 and version 1. So this is how whenever the writes or updates happen, it's always generate the new files. And from this we can say that is it's going to generate entirely rewriting the new files, right? So definitely the write is going to be slow. So that's one of the trade-off of these copy and write tables. And these are so since we have the all the updated data in the new files, so definitely reads are going to be fast. So that's why the copy and write tables we can use for read heavy analytics workloads. So that's about the copy and write tables. Let's get see how these copy and write tables will work. So here I have my, this is the same code base I am sharing in my previous videos. So here I have a Spark class that is generating to write a copy and write table. So here I am creating a Spark session. This is a standard session of creating a Spark with the Hudi configurations, and I am going to create a table of type table schema. This is a table schema, and I am creating a rows. And whenever I am writing it into the table, I am mentioning as a table type as a copy and write tables. If you see that this Hudi data, so write table type is a copy and write tables. And also I'm creating the table partition by the city, and the table name of what is it, copy and write tables. So let's run this one and see what will happen. So let's run this one. Let's finish this uh, code job to yeah, I think it's finished. Yeah, it's finished. So let's go and review the table structure. So this is the copy and write table that I'm writing into the table. You see that it's a timestamp is like 709, just now it's created. Okay, and let's see this Hudi.property file that will have the table information or not. Yeah, you see it's having the all the table copy and write table and the table name and parquet file, cop, parquet city, all this information. And then let's go and check one of the check the parquet file it generated. So it generated the 3 parquet files for my data, for my data set. Okay, so you can see that it has the 3 files and their timestamp is 709. And you and when we let's try to read the table data and see what we get it low. So if I run it and read the table data, uh, I'm reading that same table data, and here I'm reading the table data as a Hudi table, and I am reading the table data as a plain parquet file of the partition San Francisco. So let's see the first Hudi table. When we read the table as a Hudi table, so it's returning all the rows of different cities and the fair values of it. I'm reading as a table. I'm not reading as a specific partition. I'm reading entire table. That's why it written the all the rows. So in the second read, I'm reading only the San Francisco partition files, and that having a parquet file. So I'm reading just as a parquet file. So it should be same. We don't see any difference in this case. So if you see here, I have the three records as we mentioned earlier. Okay, so now I'm going to do an update on the table, and then we will observe the changes happening. So I'm trying to update a table of the Raider D, that is of the San Francisco. Let's me do run this program and see what will happen. So if we go here, it's a 712, right? Let's see. This is the previous run, right? Yeah. You see, it generated a new file. It generated a new parquet file. You see here, the timestamp of it is 712. So that means whenever we read, this is the latest parquet file generator, right? Whenever we do the mm, updates, it's always generated new files. So these are the old files, and this is a new file. This new file will have a new data set. new data updated records. So let's try to read this uh, as a table and as a uh, plain Parquet file. So what would be output is like we should when we read as a table we should have updated row for this the rider D and San Francisco partition. But when we read it, we should have the two entries here. When we read is at a Parquet file, plain Parquet file. So let's read it. Yeah, when we read it as a Parquet file, we have the two entries. One is the updated value, one is the old value, and these two records are referred by the commit time. So it's a different commit time for the previous record to this record. Okay. So when we read it as a Parquet file, we have the two entries, but when we read it as in a Hudi table, we should have only one entry that updated fare for that partition, San Francisco. So f- with this, we can say that whenever you do an updates to the or deletes to the copy and write table, it's always generate a new Parquet files. And so when we read it as a this new Parquet file will have an updated records. So if you can see this here, I have the um, what is that? Here I have the 702 712 is the Parquet file, right? Let's go and let's try to read and see what is this Parquet file have it. This is the new file is generated, right? Compared to the other one. So let's try to read that Parquet file and see what it is doing that, what it will give it. I believe it should give the updated record. It should have the updated record. Let's see. Mm, yeah, here you go. You see, it's have an only the updated record generated. It's written into this file. Yeah, that's about like in the with the copy of write, it's always generate the new Parquet new files. That is why it's slow compared to the other Parquet files while writes. So then let's go back to the other table types called the merge on read tables. So these merge on read tables are uh, is a tables where whenever you do an update or insert new inserts or deletes, it it will not generate the entire new data file, but it will generate a new files called the log files. These log files will contain the updates happen to the original data. So with this, you are whenever the writes are happening, you are just generating a delta file. Then write is going to be faster because you are not rewriting the entire file. And these are well suited for the write heavy workloads because the write operation is going to be very faster for them. And there is a process called the compaction. That compaction process will take this all these delta files and the data files and merge them into a new files. This is a separate job as a compaction job. We can run it as per some of the configurations and then generate a new files. So with this approach, so what we can do is, so assume that you have a write heavy workloads, then you can define the a table as a copy a merge and read table so that write will be happen, and in the background you can run some compaction job for every few hours. Then it will generate a new file, then your reads will be optimized because all your latest data from in one single file. So that's one of the way we can leverage merge on read table for the both read and write heavy workloads. Okay, so let's go and create the merge on read table. Before we go on to the merge on read table, let's keep a look on this file, copy and write table structure. in the San Francisco, when I do an update, it generated a new file. There is no file called the log file or delta file here. So let's go and try to create a copy and merge and read tables and then see what it is going to do. So I have the same code except I change the table type as a merge and read table. Let's run this merge and read table, generate some data, write the data into the table. Okay, it's completed. So I have the data here. So this is the table structure. I have it, and you see that it generated files just now, 718. And let's take a look at this bucket file, Hudi file. So if you see this one, it's a table type of image on read and partition column. mm, for where is that? No, no, no. Let me let me open this file. Oh no, sorry. Here I have to go here and open this one. So if you see this one, the table type is an image and read. Partition column is a city. Part table name is and key generator class. Some of these we saw in that. And then let me go to the data of the San Francisco and see that one. If you see here, I have here all the Parquet files. This is when we generated the data for the first time, right? Let's go and do an update on the table and see what it will generate. So as per the concept of the merge and read tables, it should not generate a new Parquet file, but it will generate a log file. Let's go and do an update on the merge and read table. So I'm just again so I'm updating the fare of the rider D. Let's see. So while it's running, we can go back here. You can see that 718 is the previous one when first time the table generated. Yeah, here you go. You see, it generated a new files, but it's not of the type Parquet. It's of type log, right? So whenever you do an updates onto the table, it is not generating a entire new file. It's just generating a log file. That log file will contain the updates happen to the tables. I mean, we cannot find exactly what these files are log files, but we cannot see the exact happen. But some metadata information is here that will say that this record is updated. So it's not generating any new file, but it generates just a log file. And there is one more thing we wanted to see is, so if you see here at 729, what happens, it generated a file called the delta commit. So merge and read tables will always generate a, whenever the updates happens, it's always generate a new delta commit file. But in case of copy and write tables, there will not be any um, mm, delta commits. It's always generated commit file. That's one of the difference between the copy and write table versus merge and read well table. So merge and read table will generate always a delta commit. Copy and write generate a directly commit. And whenever we run this compaction, right, on this copy and merge and read tables, it will generate the actual commit file. Until then, it's a delta commit. So that's one of the other difference between the merge and read tables. So we generated that, we saw that one. So let's go and read try to read the merge and read table as a table and as a Parquet file. I'm trying to read all the Parquet file in the merge and read tables. So that is under the San Francisco. Let's go and run it. So when we read it as a table, it should give the latest record. uh, okay, let's see. When I read it as a table, I got an updated value of 339 Sanva Rider D. When I read it, as the Parquet file. When I read it as a Parquet file, I'm still getting the old data, because in this one we don't have any Parquet file. All the Parquet file is having the old data, but only the log file having an updated value. But this is not actual log file. So whenever the compaction happen, this log file will be removed, and the entries from this log file will be written into one of these Parquet file. So that's a difference between the uh, uh, com- uh, copy and write and merge and read tables. So if you can, okay, just to recap. So when we read it as a Parquet file, we are still getting the old value, but when we are reading it as a table, we are getting as a updated value for this one. So that's a difference. So just to summarize, copy and write will always generate a new files. Merge and write will generate a log files, and these log files will be merged while reading it, as the name says. So that's about the table types. And then what is the advantages or disadvantages, or the when do we use the copy and versus table, the merge and read? Some of the guidelines are, with the copy and write, the write latency is more, so compared to the merge and read. So if you have a write intensive workloads, then go for the merge and read. And if you are fine with the write latency, but you wanted a very good read, then you go for the copy and write table types. uh, in general, most of the people will do that. They will create a merge and write tables, that way they will get the right performance, and then they in the background they run the compaction job to merge those delta files, and that will give the read performance. And if you have a read latency workload, then you go for the copy and write tables, because the merge and read tables need to read both the base files and log files, and combine those two data from these two files, and serve the queries. So the read latency is slow compared to in merge and write, compared to copy and write. So and with the copy and write, you are always going to be rewrite the entire files. Then it's going to be IO cost more compared to the merge and writes, because you are going to generate a small delta files. These are the very high level differences between the copy and write and merge and read tables. And it was suggest like from the Hudi, they suggested like with the techniques like compaction, you can get the same performance that you get it from the uh, copy and write tables. They encourage people to explore the merge and read tables. So that's about for the table types in the Hudi. Thank you all for watching, and I'm going to share the links for this code I'm uh, showing in this demo in the description of this video. Hope you can find it. Thank you. Bye bye.